current divider rule. It is the method to find unknown current of any element connected in parallel. It is used when there is no clue of voltage. Now look at this configuration. Here there are two resistors that are connected in parallel, and we know that for resistors that are connected in parallel, R equivalent is calculated as 1 upon RT is equals to 1 upon R1 plus 1 upon R2. After simplification, we get RT is equals to R1 R2 divided by R1 plus R2. This is your equation 1. From Ohm's law, we know that V is equals to IR. Therefore, Vt is equals to It multiplied by Rt. This is your equation 2. Now, we'll put this value of Rt from equation 1 into equation 2. So, we'll get Vt is equals to It multiplied by R1 R2 divided by R1 plus R2. Now, what will be the equation of Ohm's law for resistor 1? It will be V1 is equals to I1 R1, or I1 is equals to V1 divided by R1. Now, we know that in parallel circuit, voltage remains same. So, it means Vt is equals to V1. Now, we'll put the value of Vt from this equation A into this equation B. So, we'll get I1 is equals to It R1 R2 divided by R1 plus R2, and this is divided by R1. Now this R1, it will cancel this R1. So we'll get the final equation, which is I1 is equals to It multiplied by R2 divided by R1 plus R2. So this is the equation of unknown current across resistor 1. Now, what will be the equation for current across resistor 2? It will be I2 is equals to It multiplied by R1 divided by R1 plus R2. So, these formulas are for only two resistors that are connected in parallel. In our previous slide, we derived CDR formula for two resistors that are connected in parallel. Now, if there are three or more resistors that are connected in parallel, then how you are going to find unknown current of any element? Now look at this configuration. Here there are 10 resistors that are connected in parallel. First, we are going to calculate R equivalent. We know that it is calculated by 1 upon RT is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 till 1 upon R10 for this circuit. Now after solving, we'll get the value of R equivalent. Now again, from Ohm's law, we know that V is equals to IR. Therefore, Vt is equals to It RT. Now, we know that in parallel circuit voltage remains same. It means Vt is equals to V1 is equals to V2 is equals to V3 is equals to till V10. Okay. Now current through any resistor is Ix is equals to Vx divided by Rx. Again, we know that voltage remains same in parallel circuit. Therefore, this equation A, it can be written as Ix is equals to Vt divided by Rx. Now, we'll put this value of Vt from this equation 1 into this equation 2. So, we'll get Ix is equals to It RT divided by Rx. So this would be your CDR formula for 3 or more resistors that are connected in parallel. It means you just have to calculate RT first, and then you have to write the value of Rx in this formula. For suppose if you want to calculate I1, then this formula will be IT RT divided by R1. And for I2, here Ix will become I2 and Rx will become R2. Okay. Here is your class task. Can you find I1, I2, I3 for these 3 resistors that are connected in parallel when IT is 10 amperes, R1 is 10 ohms, R2 is 25 ohms and R3 is 100 ohms. Take 5 minutes to complete this task. Now, if you take the time to compare these two divider formulas, you will see that they are remarkably similar. Note that the ratio in voltage divider formula is individual resistance, that is Rn, divided by total resistance, whereas the ratio in the current divider formula is total resistance divided by individual resistance.